Okay, so today we're going to work on an Atari 2600 that was sent to me for not powering on. I apologize, I've already taken it all apart, which is relatively easy. It's just four screws on the back of the case. Literally, the case just pulls apart, and there's not even any screws holding the motherboard in at that point. You just lift the motherboard out. So anyway, I didn't think about getting this started until I'd already gotten into it, but I tested the power supply. The power supply is supplying the voltage that it's supposed to. Um, and what I did discover is that one of the main capacitors on it is failing, and it was the internals of the power jack are loose, and it was creating an internal short within the power jack. So we're going to replace that. And then part of the reason I decided I wasn't going to do this was that's not very exciting, but I decided to show usually when I do these older units, the Atari 2600s have a variety of components in them that, because they're 30 some odd years old, are due to fail, so to speak. And so it's fairly inexpensive to just go through and replace the known things that fail on these boards. So I thought I'd show that doing that it doesn't necessarily mean that the components on this board are testing out bad, because the only thing that I've really tested out that's having issues is the power jack, and this main capacitor is just way out of spec, which is not unusual for a 30-year-old electrolytic capacitor. So, but this capacitor often fails on them. The power MOSFET, while it checks good now, is the other thing that can go. Um, So these two caps down over here, these two silver ones, often fail over time. Those have to do with audio. And basically, any of the electrolytic capacitors on here are this is an original board. It has nothing has been replaced on it. The date stamped on it is 1980, so it's literally a 31-year-old board. So I charge kind of a flat rate to fix these. And so I just include in that going through and doing all of this, because it just seems like the right thing to do. The only thing I wish I had that I don't have is the switch that I believe. Oh, I guess I can find out which switch is this. This is the channel 2-3 switch, I believe, that switches it from broadcasting on either channel 2 or channel 3. It's pretty corroded and rusted out, and I don't have another one of these. So unfortunately, that's gonna have to stay. It does still work. So that being said, we're gonna start with the um, known definite bad things, which is this power port and this capacitor, and then we'll just start going through and swapping things out as we go. So not necessarily a terribly exciting video, but I feel like I don't have anything. I do lots of repairs and I don't record most of them. So I feel like maybe I should put something up so people know what I actually do. So anyway, again, I don't know if I showed this before, it's the classic Atari 2600 unit that somebody brought me. I actually also fixed, for the same customer, an Atari Jaguar system quite a while ago. But anyway, so it's nice when you get repeat customers because you feel like maybe you're doing something right. Who knows? So we'll get started on this and take off this component. We'll get started with that. I may just, there's so much solder on here that it'd be wise to just start with my solder iron and some braid rather than clogging up my. All right. ding of my siren. And I've got this old. So if you ever land up, if anybody watching this, which does this as well as a hobby or for a living, I have this really old Antex flux. It expired in November of 2020. But what I find is on jobs where the flux isn't really critical, even this expired stuff still helps. And so on kind of non-essential stuff, I saved this great big tube. I shouldn't have bought because it was too much at the time for the amount of jobs that I was doing. But anyway, and background noise is my extraction fan, so apologize for that if it's showing up in my audio too much. You can see it pulls the magic smoke right away from me. It's very nice. So on this particular connector, it has one ground pin, which is this one towards the leading edge of the board, and then it has two pins that are connected to the positive. I guess it doesn't need to be said. You don't want to bridge this pin to this pin because then you're just grounding out the plug. I think most people understand that. But these two back here, you could actually just put a blob of solder across and it wouldn't matter because they're both going to the same place. But got enough off of there. Take my handy dandy pump if it will fit over these legs, and it probably will. Go away, smoke. Set this down where I hopefully don't burn anything with it. See if this is loosened up enough for me to do anything with it. On these older boards, sometimes just time and crud also has them somewhat attached to the board, but you have to be careful. You don't want to screw up any of your traces. You get a bigger nozzle for this thing for some of these great big things, but I'll probably fast forward when I put this up. We'll have some fast forwarding software for this part. Tad bit on the boring side, I know. And as would be expected of this era, this is all just appears to be leaded solder. I don't think this. I feel like it wants to come. I'll just put my hand on my desolderer back there. That would have been painful. So I got that one out. Pretty straightforward. I'll just go through and clean this up just a tad. We don't even have to. It looks pretty darn good, but never hurts. Probably enough of this braid left. Okay, these aren't hard jobs, but kind of enjoy them. It's kind of cool bringing stuff back to life that you played with as a kid. At least I did, being an old man and all. I remember being in my teens, and when this first came out, I was lucky enough that our family actually somehow we cajoled our dad to purchasing one of these. You know, it's funny as an adult, sometimes you look back and you feel bad when you realize what this actually cost back then. These things are pretty pricey for just an average wage dad to purchase for his family. So all kinds of things I appreciate my mom and dad for now that I'm older. And I probably didn't appreciate them as much as I should have. My mom's still alive, so I can still thank her, but my dad has since departed this world, so it's kind of hard to let him know. He was a pretty good dad. So I'll just flux this up. And I don't have any solder ready for my stuff, so probably fall out while I'm trying to. So I like to, I don't buy all different kinds of thicknesses of solder because I find if I just quadruple up the wire, it works fine. So why bother having all these different thicknesses? I just fold it over twice, and now there's basically 4 strands of this, so it's quote unquote 4 times thicker when you're doing big components like this. Just twist it together so it handles nicely. Clean up my tip. Get a nice bob in the well of my big soldering iron here. Just kind of tack it initially so it kind of holds into place for me. And work on this front one so it doesn't unsolder the back one. I really need to get new glasses because I literally cannot see what I'm doing. I've done it enough times and you can kind of just tell, but we'll have to pull the magnifying light down here and get a better look at this just to make sure. I literally kind of operating on touch right now. All right. Let's see what I've actually done. Yeah, I need some more the back too, but you can always add more. You don't want to. Well, not that it matters, but when you add too much, you're going to bridge things. Not that you can't break it off, but fluxes are friends. So that's that. I learned that from well, actually every technician that does videos, but I remember the guy that does art of repair used to always keep reiterating when I was first learning. If you ain't fluxing, you ain't soldering, and it's so true. Flux makes such a huge difference in making things turn out the way that you want them to. So we'll clean it all up when we're done. But That should be good. Give it a good jiggle test here. Solid. Anything should be bridged, but hey, you don't test, you don't know for sure. So these back two should make it beep because these are actually connected together. But I should not get a beep here, and we don't. Or do we? That was weird. How did that happen? All right, that was weird. I don't understand why initially it was beeping because I must have somehow been touching something else and not realize it. All right, that's what we want. We want beep there, no beep. Beep there, no beep. I think my machine had a minor freak out. So we'll clean up our flux. Here we will. Let me get some alcohol and Q-tips that I seem to be running short on. Oh, let me pause this and let me go grab that. That was a relatively short pause because as I turned around, they're right behind me. But restocked my benchtop Q-tips. So it looks like I need to buy another box of Q-tips here soon. Q-tips are the unsung hero of the microsolder technician. I can't tell you how many boxes of these I go through, but it's probably close to a box a month. So, all right. Let's just wrap this up before it travels too much further. Handy dandy garbage can. Oh, I could have used the other side. See, this is why I go through too many of them, because I didn't even use the other side of it. But in fairness, I think it's because it was so gloppy on that one side, I didn't want to get it all over my hand when I flipped it around. I will say that the downside to, I was talking about how I just used the older flux initially. Actually, towards the end of it, I don't know if you guys noticed, I did use my fresh, non-expired flux when I resoldered it. But the older flux definitely gummed up the board more than the newer stuff would have. It still removes, just it's a bit gummier during the removal process. And this board, part of what I'm cleaning off here, this board kind of had an uninvited family that had apparently at one point lived in it. Thankfully, they were no longer living in it, but there's plenty of evidence that they had lived in it, which you get used to if you do this for a living. It's really not a condemnation of anybody's particular, this has been around for 30 years. These are warm inside, and once one or two get in there, the word spreads. They can become a home even in the neatest of most sanitary of homes. A lot of people have no idea that some of their electronic components have turned into a nesting place for critters. So that may have been what helped short out this plug. All right, on down. So that's that. But now that I'm not staring at magnified, get rid of some stuff over here. There's a lot of sticky stuff on this. I literally just started working on with flux and stuff on it as I started the video. I had not done any micro soldering on this board other than disassembling it, doing some ESR measurements and some of the caps. I really hadn't done anything else before. I was like, yeah, I should probably videotape this. So this is all old factory flux and animal deposits. So anyway, we'll give that a good 99.9 isopropyl alcohol scrub. Take and wipe. You can see how brown this is turning. So they did use really high resin content flux back in the day. And you can tell when you look at some of these boards because you get that really brown, looks almost like pine sap. Well, because kind of it is. Or Google up what why they call it resin or rosin rather. Still really sticky. So usually I wouldn't get this into the cleansing of it, but this is areas where this is just stuff that's on there from before, and rather not keep sticking my hands in it. I know I should wear gloves. Gloves kind of annoy me for no particular reason, so I tend not to wear them unless a board is super nasty. But I did vacuum and take this one out of the shop and blow it and vacuum it and brush it, but I hadn't used any isopropyl alcohol on it. You can, I don't know if the camera's picking that up, but you can see how now everything's all washed out because I have my light turned. But this is really brown in color. Of course, I also have, tell I don't do videos very often. I have all kinds of lighting issues here. Anyway, this is kind of nasty. It's turning like beige. But at least it doesn't feel all tacky anymore. The whole board was tacky and icky feeling. So move that off of there. So I don't know if my camera kind of sucks. My whole setup for filming kind of sucks. So I don't know if this will work, but oh yeah, it shows up. See there you go. Atari Incorporated, and if you look down there at the date, 1980. So this is a 31-year-old board, which is decently aged. So next, um, we're gonna do this capacitor. I'm just gonna take it out and go from there. You have to be careful not to get too aggressive because you can cause the pads to lift. Should be enough to. And when I'm pulling these out, sometimes I still like to apply a little bit more heat, just again, make it glide out of that hole. There it goes. basically out. So the positive end was towards the edge of the board. It's marked on there anyway, even on the back. And then the positive end of these um, is always also this ridge part is the positive end. And then the other way you can supposedly tell is they'll line up this arrow with the negative end, but that's a little bit more sketchy because they don't always line up. So you could, but it is pointing towards that lead, I suppose. I guess for educational sake, we could test this 30-year-old capacitor out. I've got DER EE meter here. Let's see if we can set this up so everything can be seen. It's like, so let's see, get positive this way. Let's turn this on. So what is this? Is supposed to be a 2200 microfarad. And I will tell you that a good LCR meter is actually going to read lower. In fact, we can show that too. It's going to read lower than your multimeter because multimeters typically put out all of, well, some of them like 8 hertz to test a capacitor. And the lower the hertz that you put out, the higher the capacitance it's going to read. Sorry, I know you guys can't see this, but let's see. All right, so we set it to capacitance, and it's reading nothing. Okay. Why is it? Hang on here. But it's up in a high frequency. Let's change that 1 kilohertz. So most of these spec-wise, you're supposed to read them according to the data sheets. The capacitors at 120 hertz. So there we go. And see if we can get that to show up on the screen. So it's reading 2.52 millifarads, which is, that's not bad. It's 2,500 microfarads if my brain. Now I'm questioning myself as to what MF. Let me pause this. I just want to look that up because I'm pretty sure I'm right. I'm pretty sure it means that it's reading 2,500 microfarad as 2.52 megafarad or whatever the M stands for. Let me double check. So yeah, it's reading in millifarad. So 2.5 millifarad is 2,500 microfarad. So it's actually a higher capacitance, which is not an issue in most devices. You can put a higher rated device in. So I'm just curious now because, and to be honest with you, ESR on something that's not associated with a switching power supply really isn't that big of a deal. And it actually has a really low ESR, 0.1. So there should be nothing wrong with this. It's funny, when I say this, what happens when you test things in circuit. So I don't know if my leads were hitched up wrong, but that actually isn't bad. Well, and just to show you, like, so if I put my multimeter into capacitance mode, normally it would read higher, but because I'm doing this on camera, it won't. We'll end up with something bizarre that I wasn't expecting. But let's see. So let's switch out here. There's my multimeter. Positive to negative. Yeah, so it is doing what I said it would do. Okay, so this is reading 2,900 microfarad or 2.9 millifarad as it's showing on the screen. But So it's even, so the other one was basically reading 2500 microfarad. This one's gone up even higher at 2900 microfarad. I don't have any way of, I don't have an oscilloscope we could actually test to see what hertz this is testing with, but something relatively low, which is why it's obtaining such a high number. So, um, huh, let's grab the replacement that I purchased and go from there. So here's my replacement. Um, well, heck, since we had this one out, let's go through the replacement and see what we get all the way around. All right, and there we are. And now we don't want ohms. We want, there we go. Farads. So you can see this one is closer. So this is reading 2000 microfarads, and this is supposed to be at 2200 microfarad. But remember, these are all 20%. So that's a big variance. It's a variance of 400. So at rated at 2200, this could be as high as 2600 or as low as 1600 and be considered within spec at a 20% variance. Um, so that's that. So our more sophisticated, although still a relatively El Cheapo device, but actually for the price, this thing is pretty awesome. Um, so let's get its capacitance and ESR value on our brand new one here. Oh, and surprise, surprise, it actually decided to read it out in micro farad. So you can see it's a little bit lower. This one is reading. I am reading it at 120. Sorry, I have to tilt it to see it myself. So this one is I'm reading at 120 hertz, which is considered the standard for reading these by the data sheets. But you can see on the ESR reading, it's not even picking up the ESR. Now, I can actually raise the frequency that it's testing at and actually get an ESR. So when you're testing in circuit, a lot of times we'll do it at 100 kilohertz, and then you are getting a super low ESR of 0.05. But you can see considerable difference in the reading of the capacitance when you suddenly increase. So I went from 120 hertz all the way to 100 kilohertz. Um, so many orders of magnitude greater hertz, and it dropped from 1900 microfarad to 12 microfarad. But anyway, but it does allow you to, if you standardly test on a board with 100 kilohertz, it gives you a way of seeing that. So you can go on YouTube and look at all the reasons why you do that. It basically has to do with the fact that you're charging and discharging the capacitor fast enough that you're getting the true series resistance of only the capacitor and not the things attached to it. But anyway, blah blah blah. So we'll go ahead and change it, even though the other one, the values, they had drifted, but it was technically still within specs. Uh, so, all right, so positive is towards the edge of the board. Positive, negative, put that wire in there, get it down where it looks nice. good. I just dropped my discharging resistor. Not that this should be very charged, but you know, I've learned the hard way. Don't just grab either leg of a capacitor before discharging it, because sometimes it will wake you up. And if it's a large enough capacitor, it will put you to sleep permanently. So be careful. So with these, usually if I bend them out now that they're in here just slightly, kind of holds it in place. Clean up around theirs. Let's do that before we get too far ahead of ourselves. Melt anything. I like to scrub away from the edges of the pads. I don't lift the pad. Use a nice new flux. Go. Out. I'm forever losing my solder. Beep. Magic smoke. Go where it won't kill me. Oh. All right. Yeah, you really shouldn't try to use like just this much. Can't even. But I was down to like a quarter inch of solder in my fingers, and you get pretty close to your 600 or 700 degree Fahrenheit solder iron tip. If you like your fingertips, probably should watch how I did that. Do not follow my example. These off. I like to throw these away. If you leave various wires on your bench and you're working with electronics and you turn them over, they can stick to the bottom of these boards and end up bridging things later on that you didn't want bridged. Let's turn it over, make sure it looks all right on this side. It certainly does. All right, so we got that changed. This chiclet and this are the other two things I for sure always do. Um, let's see. I think I have the right components to do that, but it'd be my luck that I don't. So let's see. I think hold in here. We'll do that first. All right, sorry about that. Back, just got confused because the other ones that I've worked on, they were slightly different. This is a slightly different revision model. So what we are changing is the one that I pointed to. I was just, when I looked down, I was wondering why I had two of these, but I didn't see. But some of the models have two caps in this area. This one does not. But anyway, I just wanted to make sure I wasn't supposed to be changing one of these other little chiclet doohickeys. But the answer is no, that if on this revision, there's just one here, that's the one that we take out. So anyway, let's get on that. Okay. All right. These are not polarized, so it doesn't matter which direction they go back in. So that's helpful. I need to get my other glasses. All right. All right. So we'll start with this little piece that I broke by accident. Next up, my heart to beat. Excellent. All right. Right. Look at that. Looks good. Right. Okay. So let's do the um, power MOSFET and then the audio chips, and then pretty much done. Let's see. It's 3 there. Yeah, some questioning myself. Always trust that little voice in your head. Even when even the few times it turns out to be wrong, you'd be glad you at least paused. All right. Got that, this. Need a Phillips head. Save that screw. Wiggle this off. Be careful that we don't break our. Go. Clean that up. Keep forgetting to remove my alcohol too. All right. MOSFET. New MOSFET. I like to gauge where I want to bend it by lining it up first. So it's going to bend just slightly below where the legs change size. So what I do is I stick it all the way in and visualize where I thought I was supposed to bend it, which is about there. See if that actually works out. Not quite. Higher, higher. I just like to get it all figured out before I get thermal grease all over it. There we go. And it also is important because the screw hole, you want, I'm doing this totally out of camera. Tell how often I do this stuff on camera. You want the screw hole moves out of the way. Glue be gone. Ah, all right. You want this screw hole to line up with the hole in the PCB so that you screw it on nice when you're done. So anyway, so now that we've got that, I'll go ahead and remove it. Kind of, sort of, or at least bend it up out of the way. Then remove it. All right. Oh, that old thermal grease is quite sticky. So hand wipes are your friend. I'm almost out of them. You don't think about it when you order a whole bunch, like a couple of years ago, and then all of a sudden you realize, oh, I must have pulled the last box out of there a while ago. Now I'm almost through that box. I already ordered them, but they're not going to be here for another 3 to 5 days. All right, there's that. Thermal pads and adhesives. So that's where my thermal paste is. this doesn't require some insane MX4 or whatever. Things aren't generating that much heat, so let's use the same stuff factory used. Sure we will. This cap sucks. There we go. So those of you that are like, why didn't you use MX4? That MOSFET has been on there 30 years. That style grace. Um, they just don't. This thing isn't demanding that much of the MOSFET. So you're not that you couldn't, but you're somewhat wasting your own money. And this is more than enough for the heat requirements of this particular device. So definitely on GPUs and CPUs, I use really good high quality Arctic Solar MX4, MX5. I like the MX4 for some reason, but whatever. That stuff will do its job. The thing I actually like about this old style paste, and why I like it on MOSFETs that aren't being overdriven, or is it also doesn't dry out seemingly at all. I'm sure it does, but like even this stuff, 30 years old, wasn't half bad. It's still gooey and tacky. You know, a lot of the current more um, thermally efficient paste and stuff turn into powder in a much shorter time than that. So there's that. Let's see where our thermal paste came through a little bit back forward with a screw. And all up, thermal paste. All right, same thermal paste off fingers. This is why, Jim, you should wear gloves. Yes, yes, it is. All right. You guys can see what I'm doing. It's kind of dark, but some kind of grunt work at this point. The most interesting part of this video will be after I do all this, does it actually power on and work? Because it should. Um, almost, I just got a couple more components after these that we'll do the audio ICs. It's always a nice touch. Then we'll adjust see if the color needs to be adjusted. And we'll be done. And client will be happy to get back her vintage gaming machine. These are kind of cool. I'll bring my magnifying light back over because again I'm soldering blind literally. I can barely tell there's pigs there. I'll put a touch more on this side. And every time I do stuff like this, video can't be seen at all. Apologize. Try not to burn things at Thunder Sucker. Great. My big long piece of solder that we did earlier. Start that one up. Quadruple that one up. Get this out of the way so you guys can actually see. So the more you kind of twist these together, it works better, to be honest with you, so the strands don't start separating into single strands in the middle of your soldering. I was kind of lazy in the first one. I guess some of that, probably not because the camera system sucks, but actually kind of was an issue a while back when I was trying to do something. It's good to be kind of partially ambidextrous. That's good. Soldering. That's partially ambidextrous. Reading right with my left hand, but definitely looks quite a bit different than my right hand. It's actually quite legible. I think maybe from playing the piano and so forth at a young age, maybe that's made the difference. I don't know. I'm going to trim these a little bit. I don't like how much they're sticking out. You often don't have to, but the way that one laid down, I prefer these being a little bit shorter. They don't slot in and mute. Seriously, if you don't wear glasses, at the very least, close your eyes before you snip things like that. One of those actually shot off and hit me in the forehead. Um, but or put safety goggles on because that shooting into your eye would be totally unapproved. So thankfully, I've worn glasses for a while now, and I've had lots of things ping off my glasses. All right, so let's get on to the nitty-gritty. So still on camera here. So the last two things we're going to do is these are audio capacitors. They have to do with the audio channel, and they often land up crapping out. So we'll do those as well. Actually, I see something just because I'm OCD. There's still thermal paste on the brand new power MOSFET that I put in there. Look pretty. Right. All right, into the home stretch here. So I'm trying to remember to put my tools back where I found them. Looks easier. So we're gonna flip this over. And these guys can go back. They're not polarized. It's the exact same part. So the question, I guess, which would make sense is, being as this didn't power on and you have no idea if these need to be replaced, why are you replacing them? And I think I've answered that, but these are the things that commonly, according to people much smarter than me, eventually go bad on these units. And the parts are so inexpensive that mostly what the client is paying for is my time. So why not just, refresh this thing up, make sure it can last another 30 years, the way I look at it. So turn this off. We don't need this anymore, I don't think. These are the last two components we're doing. So let's get this. So I've come close to touching it like 8 times during this video. So we'll limit the chances of me screaming bad words. All right, and now we'll see if we can get those out of the board. like my, I can never find them. Oh, I did find them. But I like these tweezers for this. Good Lord, I really need to get new glasses. This one is more willing to come out probably than another one. Probably gonna have to do my little trick with the solder iron on the back of the board. So sometimes what I'll do is come through the middle and underneath them so I can kind of lift, but I don't want to go over top of any of these other components because you could crack them in the process of trying to do this. So let's keep this and push. Well, I should say bend and push is what I meant to say. Keep bend and push because the legs aren't really straight. That's part of the reason they don't come out. So I have to heat them. Also try to straighten them out a bit. Push them where they should go. I'm going to apologize in advance. I think I'm going to need to grab my microscope light. It's going to wash out everything that you guys are able to see, but I don't want to screw this up. All right. Okay. See if I can grab any of them out now. Oh, I see. I need to, these are soldered pretty good from the other side too, so. Ready then. It's I turned off my solder sucker too fast. And to be honest with you, probably, you know what, the fastest way to do this is just snip these out. Probably. No, we'll try doing something else before I snip them out. Being as they're probably, the only reason, they could very well still be good, so I don't want to, I guess I won't destroy them. Not that it really matters, but I'm weird in that if it's still an okay component, I don't want to kill it unnecessarily. There it goes. Kind of cool looking components. It is funny how some of the vintage stuff, I don't know, it just has a better look to it. Oh, you guys see what I'm doing? I don't know. This is why I don't make videos, guys. But I really thought on my website I need to show what it is I do because I don't think a lot of people know. I've had a couple of clients tell me that I need to do a better job of sharing my skill set with the public around me because they had a hard time finding me, and um, so that's what I'm trying to do. This this particular job is not necessarily the most complicated diagnostic wise. Uh, but thought it'd be interesting. Me, these old, if you're in my generation or thereabouts, some of this old stuff is just interesting. I think I'm melting it. I am in my quest to not wash out the video. I'm not being able to see what I'm doing with my crappy glasses. The component I was trying to save, I partially melted. It's probably still all right, but the plastic coating around it, I got my solder iron on, and Try to untouch things that you want to touch. Bring this all the way up. Come underneath like this, and then wiggle. There we go. All right. So I've got both of those out. They will go in my bag of removed parts. The other thing I like to do, I like to show my clients what I did. I'm not going to usually send them the video that I just did. So the best way to show them what they paid for is to hand them the bag of things that I replaced. So let's see here. Hopefully I have to, yeah, I need to get some brick and clean those out a little bit to make sure that these stick down easy. Lots, lots of flux. All right, and then the other nice thing about these boards, which you can't, once again, can't see because I'm left my light up, all the components are just, you still see that occasionally in some new stuff, but it's pretty much not something the company's bothered doing anymore. Granted, in a lot of boards they can't, there's not enough room, but even on things where there is, there's this whole attitude now in the electronics industry that why would you help people try to fix things because that only limits your sale of new things. And they won't admit to that, but there's no reason for not sharing schematics. Schematics don't help a competitor um, build your product, which is what a lot of people think, and so they side with the manufacturers. And the funny thing about that is so if I could totally build an iPhone just from the schematics, um, if I was a manufacturer, I would just pay somebody to sit down, disassemble the iPhone, and test all the components, and I would have all their values. I mean, yeah, it might take a week, but if it's a multi-billion-dollar industry, how much is it really out of your pocket to have somebody disassemble something and just test all the components to see what their specs are? So because that's perfectly doable. Like if you have the right like I had that meter out earlier, that's just $100 some odd meter, and I could get something simple like this. I could basically get almost all the values I need with that. And from companies that can invest in even better diagnostics and oscilloscopes and all kinds of things, you literally can make a schematic of a device just using that stuff. And so the only people it's hindering are technicians trying to fix things. It's not an intellectual property thing. The device itself, this itself, is a schematic of itself in 3D. It's just that the schematics, especially on devices that have multiple layers, um, allow much faster and efficient fixes, therefore making uh, some fixes viable that wouldn't be if you had to spend an extra 3, 4, 5 hours because you didn't have a schematic at that point. Your time in this profession, your time is your commodity. And so, like when I do things like this, I don't share with when I charge in videos because the videos last forever. And even if I said when I filmed it, I just learned the hard way. It's best not to talk about it. It really has nothing to do with me caring about people knowing what I charge. But I charge a flat rate. Um, I usually don't video these because it takes me, because I'm not very good at videoing, substantially longer to do it when I'm videotaping the process. So it's part of the reason why I hate videotaping. But like I said, if I've had 2 clients in the last month, both say, dude, like, I don't think people understand what it is you do. And so I am attempting to rectify that by I shouldn't say wasting, spending a lot more time than I normally would. Because if you watch this, you're thinking, you know, how much you're going to charge for this, dude? You've spent a lot of time on it. And that it would actually be a valid point, but I can tell you that this is already taking me well over twice as long as it normally would because I'm videotaping it. So probably much longer than twice. That's all right. I'm doing it on a day I normally wouldn't be working. It's New Year's Eve. So my wife and kid happen to be out of town. And so why not? Um, I do have a couple other repair jobs. So I should make fun of one of my, let's say, relatives. So I don't help the person who sent me something to fix. And I feel kind of bad because it was a relative. I mean, he had the right idea for what he was trying to do. This quality product, but he didn't do anything wrong in the installation and stuff that he did. But he totally picked the wrong thing to replace, and then replaced it with something that he basically shouldn't have. That really slowed down this product a lot. And he paid. Well, it wasn't too bad to mail it to me, but I do feel a little bit bad that it turned out not to be something where I could employ my limited skill set to show off and say, aha, this is what I discovered. I just took that the wrong. No, I did not. Why does the holes in it there? So that's. They should be above it. So it looks like one of the holes is not cleaned out. That's what I'm seeing. So let me get my wick that I won't be able to find now that I set it back down on the bench. My cutter's in it. Long. I put my brush back where it belongs. Oh, here's the wick. I put some flux. So I don't have a hole all the way through, which with my absolutely just typically bad webcam that I use for filming these, unlike people that have nice camcorder cams that they have in 4K resolution and can cause them to focus in and out, zoom. That is not the case here at iFixer3, which I'm not going to change the name of my company because I find it amusing, but I can't tell you how many people, including my mother and other tell people about me and refer to my company as iFix for free, which of course a lot of people are very, very, very interested in. And you know, I have to then kind of let them know, no, that is not the case. I wish it were. I wish that I could just do this for fun and that I had enough money that I didn't care about charging, but that is not true. Like most of you, I do need to make a living. So it's iFix for free because I don't charge if I can't fix things. Because that allows people, it allows me to feel comfortable accepting devices that I literally have no clue because I've never seen them before. And um, so I can be honest with people and just say, well, I've never worked on that before, but electronics are kind of electronics, and many of the principles apply across many various devices. So I have a reasonable expectation and get that fixed for you. And if I don't, it doesn't cost you anything. It's not like I'm trying to make money off bench fees or something. And I will say, like, anybody else, actually watches these videos, particularly some of my past clients, doing this has taught me that, like, there are so many really nice people on the planet. Because I've had people pay me for things that I couldn't get fixed that I said, no, like, seriously, I live by my, and they just really were appreciative and wanted to pay me something anyway. So I will say I don't turn that down. A couple of them it did take forever, uh, and so but it also wouldn't bother me if they didn't because I learn from everything that I do, and so it's kind of like my cost of tuition when I get something that I can't fix. Um, it's I'm paying my dues um, to hopefully in the future be able to fix that. So That's the way I look at it. There are things that I don't work on. They're pretty clearly stated out on my really decrepit, poorly designed, needs to be badly updated website. But I don't work on TVs. Uh, A, just not that interested in them, and B, they've got so big that in my little shop, um, they're just really hard to deal with. So with the price of them coming down, I don't blame everybody for owning like a 65-inch TV. What the hell, Why not? But trying to haul that thing into the shop here, uh, not my cup of tea. So there we go. After I've rambled on to try to keep it somewhat entertaining while I do all this stuff, we have everything replaced. So very quickly, what did we do? So we started off by replacing the DC import jack. We then replaced the main power uh, capacitor filter, um, replaced the MOSFET, replaced the capacitor that works with that. I'm so tired. And then replace the two audio capacitors. And so I'll pause this. I don't really need to assemble this. That's the beauty of these two. But I do need to move my cameras around because I can't show you guys what it looks like from this station here. So we'll pause this. I'll move my camera over and we'll see if this actually. And I put my little light right across my face. I am an excellent videographer. So we'll pause this and we'll see if this fires up. All right, I'm laughing because I had to hang my camera off of a tool chest. But anyway, I haven't even turned it on yet, so I honestly don't know yet. Do have it set for channel 2. Also, I attached up, the client also gave me a joystick that wasn't working, and I did find these had these little foil things inside of them that click up and down. But anyway, I fixed that. I believe I fixed that, but we will find as I'll move my chair right into the camera. Guess we'll stand. See if. All right, it's all tilted. But anyway, so let's get the TV on channel 2 in TV mode because otherwise we're not going to see anything. And I need to do that. I need my remote because these wonderful Samsungs through the manual button on the TV. There's no way that I've found to actually be able to control many of the functions of the TV. So it's kind of bad. If you lose your remote, you're kind of screwed. All right, TV, it's probably already on channel 2 if I remember right. It is. All right, so we have not yet plugged in the power cable. We should plug a game in there. So let's see, we have our choice of Berserk or Tapper. Let's go with Tapper. Which way does this go? Because I have this out of the case, I'm not sure. I think I chose wisely. Seems like that went in, although there's no reassuring click or anything. All right, so then we'll plug in our power supply into our new port. Oh, it fits nice. Feels much better than the older one. And then we'll turn this sucker on. Hey, that is awesome. Well, because of my absolutely crummy camera, well, I guess I should see if, how do you play this game? Oh, it's probably in demo. Hit the button. Oh, there you go, just hit the button. All right. And I'm either have not fixed the joystick or I'm plugged into the wrong joystick port. Sorry. See how many times I can block the view of the video I'm making. I think I just died. Well, I don't know if those audio ICs were bad, but well, that's no fun. You know what? It did. The fire button did work, so this is actually kind of bothering me that maybe there's something else going on with this because I do have another joystick to test with it, but which is the reset? This? Hmm. Well, that's kind of frustrating. We may have some more diagnostics and repair to do yet. Let's try the other joystick. Nothing. Well, let's shut it off. Which was this guy, I believe. Let's remove the cartridge. Let's take the power out. Well, we have power, which is more than we had before. We obviously have other issues. So let's do this. Let's plug both joysticks in. Okay. Let's see. This makes me question the capacitor I put in. Because the positive end of that capacitor runs right into the joysticks. Ah, you know, I think I'm going to touch up a little bit around that capacitor. Never just assume that you did things right. So I'm going to put a little bit more solder around the joint, especially on the positive leg of this capacitor. You won't be able to see this, but it's going to be a quick job. But the positive leg doesn't quite have a nice little solder pillow around it, which I didn't notice. At least on this side of the board it doesn't, and it probably makes zero difference, but hey, when things aren't working the way you expect, always look at what you did first before assuming there's yet another problem with the board, although there very well could be, being as this board had zero power when I started. So we've made significant progress, but we are not there yet. But let's get some solder there. I know that the trace comes directly off of. There we go. And let's I'm also questioning myself on the chiclet one that I did. There. Hmm. Probably should have paused it, but you know, whatever. This is real life. All right, so let's put this in continuity mode and check if we're actually connected. Yes. All right, well, so we changed that. Audio's obviously working. I don't know, I'm a bit miffed. Let's see, let's just hitch it up again. Try a different game. Maybe Tapper's got some issues. We only got two. This one is called Berserk. Let's try not putting the game in until after we've hitched up. I don't know. I haven't played with one of these in 30 some odd years, so God, if I remember what the order of things are supposed to be, I wouldn't. These are old serial connectors. Wouldn't think it would make any kind of difference whatsoever. In fact, 99% sure it doesn't. But hey, and helps if you've got the RF cable, coaxial video cable attached, so you can see if things are working. I guess for shits and giggles, let's see. So let's see what my game reset, game select, TV type, color, and then on or off, and it's in the off position. Excellent. Let's just feel like it's safer while it's off to put the game in. So I'm still going to do it that way, even though I said I was going to switch it up. But it just seems like, see, that one clicks in. It just seems like putting it in when it's already on just doesn't seem wise to me. Short something out. Anyway, I guess I should find the actual instructions to these. It's actually the first one I've had where opposite that this particular issue arose, so I'm a bit perplexed. All right, let's turn this sucker on. All right. Oh, I think I instantly ran into the wall. Hey, we've got movement. Oh, apparently. Oh, I do remember this game. Oh, I remember this game. Get you, little turkey. This must be an easy mode or something. This is incredibly simple. Run, run, run! All right, well, which joystick is this? This is the original Atari. Yes, I'm gonna die. All right, so so this one she said already worked. This is not the one that I worked on. But I am quite pleased. I was a bit confounded by the joysticks not working, to be honest with you. So that's a funny thing about making videos, like all the stuff that occurs behind the scenes when you're fixing people's stuff, where you're going, huh? All right. Oh, ooh, button works. Up works. Right, left. Ooh, I did fix it. I figured I did. These aren't that complicated. Whee! We'll play with this one a little bit longer, just because this is, well, I guess not that much longer. I got fried. I still find that these games mildly entertaining, even though they're so simple. All right. Well, with my oh, I'm sitting totally in front of my video. I'll have to do a lot of editing on this. But anyway, it works. So that is that's cool. So that's the kind of stuff I do, and you now know why I rarely make videos because I'm horrible at them. But that is Atari 2600, fully restored. Came to me with no power, and I'm horrible at making videos. And don't take some anti-nausea before you finish watching this. But anyway, that's what we do here at iFixerFree, or I should say, I do. I am the sole employee. But I enjoy restoring things and fixing them. So That's it? All right.